Hello class, today we are doing lesson 11.5, appropriate measures. So what we're going to be looking at here is on page 845. The Green Committee had a recycling drive where they collected aluminum cans, plastic bottles, newspapers, and batteries. The weights collected on the first day are shown. I hope this reminds all of you about me because of all of my recycling collection. I hope this reminds you of the science we're currently doing, and I hope that you guys are taking advantage and doing lots of recycling on your own. So for the cans, we have 12 and 2/10 pounds. For the bottles, we have 11 pounds. For the newspapers, we have 19 and a half pounds, 19 and 5/10. And for the batteries, we have 13 pounds. So let's look at this. Find the mean weight collected. Who remembers how to find the mean weight? So we find it by adding up all of the numbers that we have and dividing by the amount of numbers. So I added the cans, the bottles, the newspapers, and the batteries. And then I divided by how many there were. So we did that. And when I do that, when I solve, I get a total of 55 and 7/10 over 4. And when I divide that by 4, I get my full answer to be 13 and 925 thousandths. If the newspapers were not included, find the mean weight rounded to the nearest hundredth. So now I don't want to include the newspapers. So I'm only going to be adding 12.2, 11, and 13. Am I still going to be dividing by 4? No, because there's now only 3 different numbers. So instead of dividing by 4, we still just have those 3 numbers. I add them all together, and my new answer that I get is 36 and 2/10 divided by 3, which means that my new answer in the end becomes 12, and if I round it to the nearest hundredth, and 7/100ths. How does the weight of the newspaper affect the mean? It adds 2 pounds to the mean. It raises it. And why do you think that is? If we look at that, it's because it's the heaviest of all of them. So if we took away the heaviest of them, of course our mean's going to be lower. What if we took away the lowest of all of the numbers? We got rid of the lowest. Our mean would be higher because now we're only having the bigger numbers. If I took away this, now I only have smaller numbers. If I took away this, now I only have bigger numbers. What is the median for the data set? So we have 4 numbers, which means that the median is going to be the mean of the 2 middle numbers. This is our biggest, this is our smallest. So we need to find the mean of those 2. 13 and 12 and 2/10 divided by 2. When we do that, we get 12 and 6/10. So how does the median differ if the newspapers are not included? If we got rid of those newspapers, now we only have 3 numbers. So our median, cross off that, when we have 12 and 2/10. So the median, if we got rid of the newspapers, is now bigger. That's interesting. So our median and our means don't always correlate. If our mean is bigger, that doesn't mean that our median is going to be bigger. If our median is bigger, that doesn't mean our mean is going to be bigger. They all work kind of on their own. That's why we have so many different measures of variation. So, using mean, median, and mode. Mean is most appropriate when the data has no extreme values. Essentially, that means all of the numbers are bundled close together. 7, 9, 12, 13, 15. But if we had stuff where the data has extreme values, I'm going to have 1, 12, 15, 89. The data has extreme values. However, there has big gaps in the middle of this data. So it wouldn't necessarily be the greatest, but it'd still be better. And then lastly, mode. Data has many repeated numbers. It wouldn't make sense to use the mode if we had this because there is no mode. Our mode would only be useful if we had 1, 2, 4, 5, 6, 7, because that's the only one where we have multiple numbers of the same ones. So it's important to know when we should be using mean, median, and mode. Sometimes one measure is more appropriate than others to use to summarize a data set. Let's play the game, mean, median, or mode. So, for our game, we're going to look at this. The table shows the number of metals won by the U.S. Which of the measures of center best represents the data? Then find the measure of center. So, if we're looking at this right now, we don't have any extreme numbers, and we also don't have any repeated numbers. I would say that mean is the best number. If we found out the mean, we'd be adding all of these numbers up and dividing by 5, because there's a total of 5. We get 523 over 5, and our answer becomes 104 and 75 hundredths. So that means the mean, and not 75, and 6 tenths. It's my bad. So here, our mean is 104 and 6 tenths metals. That's the number of metals won on average, the mean. Let's look at number 2. The table shows the water temperature over several days. Which measure of center best represents the data? So let's look. We don't have any extreme values, so maybe we could use mean. However, we have this temperature repeated 4 times. So with it being reported 4 times, it's going to be the most common. So I would use mode, and our answer is 82. Because otherwise, it's not going to be as accurate if we tried to do median, for example. Well, median actually would be 82 in this case as well. But mode is going to be the best because it's the number that's repeated the most often. Notice, though, that it's the same. If I got rid of the 85, 78, then I got rid of the 82, 81, 82, 82, I'm still left with the 82. That's why sometimes it's applicable to have multiple measures that you could use. So let's look at example A. The prices of several DVDs are $22.50, $21.95, $25, $21.95, $19.95, $21.95, and $21.50. Which measure of center best represents the data? So again, we don't have any extreme data, which means mean would be pretty good. But I don't want to really add all those numbers up. Let's see if there's something better. This number is repeated 3 times, and there's one that's almost exactly the same, close to it. So my choice that I would do is I would pick the mode, which our answer would be $21.95. If I find the mean, I add them all up and I divide by the number. We have 1, 2, 3, 4, 5, 6, 7. I added them all up and I got 154.80 divided by 7. My mean is $22.11-ish. That's pretty close as well. That's only off by 16 cents. And if I look at my median here, I'm going to cancel out first 25, 1995, 22, and then look at, we're only left with our 21s. So again, all of them are pretty close to one another, but the mode would have been the easiest for us to use because we've got a lot of repeated data. You don't want to tell your mom, well, the prices are, I've got one for $25, one for that. You want to convince your mom. You want to say, Mom, most of them only cost $21.95. That's a pretty good deal. So let's look at this one. For this one, we've got the average lifespan of different animals. An African elephant is 35 years, bottlenose dolphin's 30, chimpanzee's 50, Galapagos tortoise is 200, gorilla is 30, gray whale is 70, horse is 20. What do we think of that? All I know is that I've got an extreme number there, 200. By the way, tortoises do tend to outlive people, so don't get a tortoise unless you plan on finding a way to, place it somewhere. So we've got that extreme piece of data there. So what would the best thing to do be? In this case, the best answer is probably going to be the median, because that means that we're getting rid of this extreme number here. We get rid of that, we get rid of this. Get rid of that, we get rid of this. Get rid of that, and then we find the median and get rid of this, and we find our average to be about 35, which makes a lot more sense. That's pretty much towards the center. Now, let's think about this. We're going to be learning about something called outliers, just like we did before. So we want to remove that outlier, the one that's much bigger than the rest. So I'm going to remove the Galapagos tortoises because that's such a big number. So 200 is extremely big. It's the outlier. So now I want to determine the mean, median, and mode without my outlier. So my mean, my median, and my mode. We already know that our mode, easy enough, is 30 because that's all we have there. If we now looked at our median, let's get rid of our biggest, smallest, biggest, smallest. We got to find the middle between there, and that is 32 and 5/10. And then lastly, if we were finding the mean, we're going to add all of these numbers up. And we get it 1, 2, 3, 4, 5, 6. We divide by 6. And I add them all up to get, I get 235 over 6. And if I divide it by 6, I get 39. That's a great job. That's what I got for all of them. That's without my outlier. Now, let's do it with the outlier and see what happens. Move that over there, but let's make this tiny 9 because that big 9 does not belong. So now let's do it with our outlier. My mode stays the same because I still have 30 multiple times. My median, now let's cancel them out. Biggest, smallest, biggest, smallest, biggest, smallest. My median is now 35. That's still pretty close to the 32.5, 32 and 5/10. It's still pretty close. But now if I added all of those numbers up together, if I added them all up, I would get, I now have 435 divided by 7, which gets it to equal about 62. Look at how outrageously different that number is from every other number listed. 39, 32 and a half, 30, 35, 30, 62. That's why sometimes when we're dealing with outliers, you might need to remove them before you can get an accurate read on the data. Determine how the outlier affects it. So we already solved this. It's about 62, 35, 30. We've got this. So the mean lifespan decreased by 23 years. The median lifespan only decreased by about 2.5 years, and the mode did not change at all. That's how we would analyze this. Which measure is best? So if we looked at this, let's determine any of this. Let's look at our outlier in the data. All of these are pretty close together, except for this $78.95. This one is almost $80, while this one is still $40. 40 is close to all of these numbers. 80 isn't close to anything. So our outlier in the set of data is that much. Determine how the outlier affects the mean, median, and mode of the data. So while we could do is solve all of this, we know that if we removed our larger outlier, it's gonna get, the mean is gonna get smaller. Because now we're only dealing with smaller numbers. So if I found this, I'm going to do this. I want you to pause and I want you to find the mean, median, and mode of these numbers with the outlier and without the outlier. So we add all of these up and we divide by the numbers. So with our outlier, we have 1, 2, 3, 4, 5, 6, 7 numbers, which means that our mean ends up being $52.33. Our median is $48.50. We get this by removing our biggest and smallest, biggest, smallest, then biggest, then smallest, and then biggest, and then smallest, smallest, and we get that to be our median right there. And our mode, the most common one, we don't have any numbers that repeat. Same if we didn't without the outlier. We still have no numbers that repeat themselves. Now that we only have 6 numbers, though, we have to find the mean of the 2 median numbers. I know I don't like doing it either. But our initial mean for without the outlier now becomes 4789. Just as I said, it got smaller because we removed our bigger number. Our median is 48. So which measure of center best describes the data with and without the outlier? So the mean price was affected the most. We changed by nearly $5, about $4.50 if that, you know. So we wouldn't want to use that. The median price changed very little, only by 50 cents. And the mode doesn't even matter because we don't have a mode for either. So what's going to be helpful? So the median, in this case, is going to be the best of our data. It's going to be the best measure of center. Let's look at our guided practice. First things first, identify the outlier in the set. If we look at this, our outlier is going to be 175. The rest of them are very close together, either in the 3s or 400s. This is the only one. We don't even have any in the 200s. Now, determine how the outlier affects the mean, median, and mode. Remember, if we're getting rid of the bigger number, our mean gets smaller. So what happens if we get rid of the smaller outlier? Our mean gets bigger. So we already know our mean gets bigger. I want you to figure out the mean, median, and mode, both with the outlier and without the outlier. So now you should have taken the time to do that by pausing. If we find this out without the outlier, when we do it without, our mean is going to be 364 and 3/10 degrees. That makes sense seeing as they're all around the 300-400 range. Our median, there's an even number, so we have to, or without the outlier, there just becomes an odd number, which is really, really easy. We get rid of our biggest, we get rid of our smallest, get rid of the biggest, get rid of the smallest, get rid of the biggest, smallest, we find that our median is 350. And our mode is going to be, again, 350, because we have that number 3 times. Let's look at it with. So this one's without. Let's look at it with. If we keep our outlier in, our outlier's mean is 340 and 6/10. Our median is 350, and our mode is still 350. So our median and mode didn't change at all, but our mean did. Our mean changed by about 24 degrees, which is a big amount of degrees. So the median and mode best describe our stuff because the temperature is misleading based on the outlier. With the outlier, our temperature is very different than without the outlier. It's gigantic. So as we can see here, there's different ways that we can check to see which measure is most appropriate. Your homework is going to be page 849, numbers 1 through 4.